Lesson 5-2. The next 4 lessons all cover a different type of linear equation, and here's your list. As you may guess, this is the one that we're doing today. And you say, well, that's all very well and good, but what on earth is a direct variation? Here are some examples of relationships that are in what we call direct variation. How far you travel in your speed, and so on. You can do this. I don't know. So now let's go to our notebooks, get the vocabulary written in the notebook. Only one definition really for direct variation. The technical definition right here. Then, so that you know what k is, that's the coefficient for a direct variation. If I take this formula and solve it for k, it looks like this. Same formula, solved for different variables. So now you have an example of a few types of direct variation, and you have your formula for a direct variation, but now how do you figure out if something can fit in that formula? Well, you have to solve for y. Nasty flashbacks for some of you from an earlier lesson. Here are a couple of examples. Letter A, you have y equals something times x. That fits our formula for y equals a coefficient times x. Over here, y equals something times x, but there's also another operation going on here. This does not fit our definition. This one is not a direct variation. Got it, number 1, bottom of page 299. Can you rearrange this? Can you solve for y? And will it fit in our formula for direct variation? And if it does, let me know what the constant is. You give it a try. I'll be waiting. So here's the equation they gave you, and you're trying to solve for y. So isolate it. First step, get the x term to the other side. Then divide by 5. You end up with y equals -4/5 x. So then you have 2 questions to ask yourself. Is y by itself? Yes, it is. Second question, is there anything being added or subtracted to x? No, there isn't, which means that it is a direct variation. And the constant is -4/5. Problem 2 starts the other way. It says you have a direct variation. Here's an x term, here's a y term. What is the formula? What is your equation going to be? So, the steps, write down the function form, substitute in what you know, x and y, solve for k, and then put k into your direct variation equation. Got it. Number 2 asks you to do a couple of things. It asks you first to find the equation. Then it says what's the value of y when x equals -15. I'm going to find my Rubik's Cube. Then we'll check our answers. And still nobody solved it. Ugh. All right. So here's what we're given. We know our variation form, a direct variation formula. And here are the 2 points they gave us. So substitute in x and y right there. Solve for k. Put k back in. Y equals -5x. When x equals -15, y equals 75. So now with problem 3, we are adding the next step. We're graphing. They give you a couple of weights. Your weight on Mars, your weight on Earth, another example of a direct variation. Here's your function form. Here's the x and the y that they give you. There's your approximate value for k. And so there's your equation. Now that you have the equation, you can put in some values, make a table, and plot a graph. Notice that they only used the positive quadrant on the graph. I wonder why. Perhaps it's because you can't have a negative weight. Go on to got it number 3. So it's your turn, and now we're on the moon. We've got our direct variation form, your weight at home, your weight on the moon, and we need to figure out what the equation is, what the constant is, and what the graph is going to look like. Go! So you plug in what you know, you isolate k, you end up with k equals 0.116, you put that into your formula, and then you make a table of values. Notice I chose to go with 100, 200, 300 pounds because it made the math relatively simple. So my x value, my math work, my y value, and then make a lovely, lovely graph. Remember, you can use different scales on that different axes of your graph. On the x-axis, every 3 boxes I went up 100 pounds. On the y-axis, every box I went up 5 pounds. As long as whatever you do all the way up or across the axis. That's fine. There's my beautiful graph. Now, often for the reasoning questions, like letter B, I say, don't write anything, just think. But this is actually a fantastic setup for a genius aha moment. They want to know if you go back to the problem on page 300 and figure out the slope of the line in that graph. This is the one with weight on Earth and weight on Mars. Well, remember from the last section, the slope formula, change in y over the change in x, which looks like that. Now, take a look at the other information in that problem, and you see that 0.38 is what? So the slope of this line, go back and take a look. The slope of that line is the same as, go check. All right, so the 2 main points for this unit. When you have something that works in direct variation, the line always passes through 0, 0. And the slope of the line is that constant k. So if k is a positive number, you have a positive slope. And if k is a negative number, you have a negative slope. And finally, the classwork for your next class tomorrow or Monday or whatever it is. It starts on page 302. Problems 10 through 28, do the even ones. I will have check sheets for you. Don't do them tonight. You're done with your math.